Hello children, welcome back. So today we are going to read about the topic of class 10. We would be continuing with reflection of light. In the previous video you must have seen that we have talked about the definitions or the terms related to mirrors, terms related to spherical mirrors. We talked about focus, we talked about the center of curvature. We also talked about the principal axis. Then we also talked about that if we take a concave mirror and we have the principal axis, this is the focus and this is the center of curvature. We also talked about f is equal to r by 2. So if a ray of light is traveling parallel to the principal axis, we saw why it passes through the focus after reflection. So it always passes through the focus. Any ray of light passing through the center is then normal. This also we have discussed. So in today's lecture, we would be talking about uh, how to draw the ray diagrams in a concave and a convex mirror. So we would be focusing on ray diagrams in concave and convex mirrors. So before we draw the diagrams, we need to know a set of rules. So let us see the rules first. So first of all, we will talk about concave mirror. So if we have a concave mirror, let us say this is the concave mirror. We draw the principal axis. This is the pole, this is the focus, and this is the center of curvature. Now we have already done the definition. So if we take a ray which is parallel to the principal axis, if this is the ray which is going parallel to the principal axis, after reflection it must always pass through the focus. So this is the focus. So this is rule number 1. Any ray of light moving parallel to the principal axis always passes through the focus. This is rule number 1. Now let us come to rule number 2. What is rule number 2? If we take a concave mirror and we allow the ray to pass through the focus now. This is our principal axis, this is the pole, focus and center of curvature. If a ray of light is passing through the focus this way, then this ray must always move parallel to the principal axis. So the rule says any ray of light passing through the focus goes parallel to the principal axis. This is rule number 2. Let us come to rule number 3. What is rule number 3? Now if we take the concave mirror again, we have a principal axis, this is the pole, this is the focus, this is the center of curvature. If we pass any ray of light through the center of curvature this way, this is rule number 3, what would happen to this ray? Now this ray, this is nothing but the line which represents normal in a plane mirror, in a concave mirror also. This is the normal. So if the ray is passing through the center of curvature, here we have I is equal to 0 degree, so R would also be 0 degree. So what would happen to the ray? This ray would reflect back. So any ray of light, the third rule says, any ray of light passing through the center of curvature reflects back. So this is the rule number 3. Okay, so let us come to rule number 4. What is rule number 4? Take a concave mirror again. We have a principal axis. This is the pole, this is the focus, this is the center of curvature. If a ray of light strikes the pole this way, if this is the light ray, how to draw the reflected ray? Now we have this line, the principal axis. This line would be the normal now. So we can measure this angle. This angle will be angle of incidence. So measure the same angle and draw the reflected ray. So this would be the reflected ray. So any ray of light striking the pole would reflect with the same angle with which it has made with the principal axis. So using these 4 rules, any 2 rules would be enough to draw the ray diagrams. Now let us see the rules for convex mirrors. Now how to draw the ray diagrams in convex mirror? We have got a convex mirror. Let us say this is the convex mirror. This is the principal axis. We have the pole, we have the focus here, the center of curvature here. If a ray of light, the first rule, if a ray of light goes parallel to the principal axis, this is the incident ray. Now we know that convex mirrors are diverging mirrors. So this ray would diverge in such a way that if you extend it backwards, it would appear as if it is passing through the focus. So any ray of light, rule number 1 says, any ray of light parallel to the principal axis, appears to pass through the focus after reflection. This is rule number 1. Let us come to rule number 2. So let us draw a convex mirror again. This is the convex mirror. We have got the principal axis. This is the pole, focus and center of curvature. Now let us pass this ray through the focus. So this ray is actually trying to pass through the focus. Now according to the rule, it should go parallel to the principal axis. So this forms rule. This makes our rule number 2. So any ray of light, the rules are same. Any ray of light passing through the focus goes parallel to the principal axis after reflection. Now rule number 3. Draw the convex mirror again. The principal axis is the pole, focus and the center of curvature. If a ray of light is passing through the center of curvature this way, this ray is trying to come towards the center of curvature. Now what would happen? Here also we have got I is equal to 0, R is equal to 0. So this ray also would bounce back. So any ray of light passing through or appearing to pass through center of curvature, appearing to pass through C gets reflected back. Okay, now let us come to rule number 4. What is rule number 4? Exactly the same way we have done in concave mirror. We have a convex mirror. Then we have got the principal axis. This is the pole, this is the focus and the center of curvature. If a ray of light is striking the pole this way, so we can measure the angle of incidence here. This is the angle of incidence I. With the same angle you can reflect the ray now. So this is R and I would be equal to R. So out of these 4 rules, so we have got 4 rules now, and we need a minimum of 2 rays to get the image. So any 2 rules would help us to draw the ray diagrams. Okay, so we will discuss the ray diagrams for various position of object in case of concave mirror as well as convex mirrors. So ray diagrams now. So ray diagrams for various position of object in a concave mirror. So we have got 6 different positions. The first one we will talk about when the object is at infinity. Second one we will take object beyond C. beyond center of curvature. Third, we will take object at C. The fourth one, we will take object between F and C. The fifth one is object at F. And the sixth position here is object between pole and focus. Okay, so let us come to the first one, object at infinity. Object kept at infinity. Now when we are saying infinity, means that the object is kept at a very large distance from the mirror. So first of all, let us draw the mirror. We draw a concave mirror and we draw the principal axis. This is the pole, this is the focus, and this is the center of curvature. Make sure that PF distance is same as FC, because focal length is equal to R by 2. So to get proper diagrams, you always use a ruler and a pencil to draw the diagrams. Now when the object is kept at infinity, we cannot show the object now. So what do we do? Because the object is at infinity, we would consider two parallel rays coming from infinity. So let us say this is one parallel ray parallel to the principal axis. This is the second parallel ray. Now according to the rule, these rays would pass through the focus after reflection. So this gets reflected, passes through the focus, and this ray also would get reflected and pass through the focus. So if you see here, these rays are meeting at F. So rays are rays. Which rays? The reflected rays are meeting at focus. So we can say image is formed at F. Image is formed at F. Now if you see, the rays are meeting by themselves, therefore the image is real, and if it is real, it must always be inverted. So the image is real, inverted, and formed at focus. Now if you see the point, the size of the image is always found by seeing the position of image from the principal axis. Now the image is formed itself on the principal axis, so it would be very small. So it is a point-sized image. Point-sized image. So this is the first case. Object is kept at infinity. Image is formed at the focus, which is real and inverted, and it is a point-sized image. So these are the characteristics of image when the object is kept at infinity. Now let us come to the second one. The second case, object kept beyond center of curvature. So draw the concave mirror, draw the principal axis. I am drawing a freehand diagram. You need to draw by using a ruler to get a proper diagram. Now because the object's position has been specified beyond center of curvature, we need to show the object. Object is represented by an arrow which is pointing upwards. So this is the object now. This is the object. So from this object, one of the rays goes parallel to the principal axis. We can use any two rules. So one ray goes parallel to the principal axis, passes through this focus after reflection. You can take a second ray and pass through the center of curvature this way. This is also a rule. So if you pass the ray through the center of curvature, it would reflect back. So where is the image formed? You can see the meeting point. This is the image. So image is formed. Image is formed between F and C. And if you see the nature, it is formed by the real meeting of light rays. So the image is real. Why it is real? Because the reflected rays are meeting by themselves, and if it is real, it must always be inverted. And if you see the size, it is smaller than the object, so it is smaller in size. So this is case number 2, object kept beyond center of curvature. The third one, you can do it yourself. We will come to the fourth one. Third one is object kept at center of curvature. If you keep the object at center of curvature this way, this is the concave mirror. I am not drawing it. You just have to follow the instructions. Pole, focus and center of curvature. If you keep the object at center of curvature this way, you will find that the image also is formed just below the center of curvature this way, and the size of object would be equal to size of image, and it would be real, and if it is real, it would be inverted and formed at C. So you can try this yourself. This is for you to try. Let us move on to the fourth one, object between F and C. Object between F and C. So we have the concave mirror, we have the principal axis, this is the principal axis, we have the pole, we have got the focus, we have got the center of curvature, and we are going to take the object between F and C. So one of the rays goes parallel to the principal axis this way, and let us draw the reflected ray with white. So the reflected ray would be passing through the focus after reflection. So this is the reflected ray. Okay, and we can pass the second ray through the focus this way. The ray passes through the focus and goes parallel to the principal axis this way. So where is the image formed? You can see the image formation. It is formed at this point. This is the image, and here is the object. Now see the size. The image has become bigger in size, and the image is formed beyond C. So the nature is real, inverted and enlarged. Image is enlarged, image is real, image is inverted. And where is it formed? You can see image is formed beyond C. Image is formed beyond center of curvature. Okay, now let us come to the fifth one. The fifth one is object at F. Let us see how the image is formed. So let us say this is the concave mirror. We have got the principal axis. pole, focus, center of curvature. We are taking the object at focus. So if we take the object at focus, we cannot pass the ray through the focus now. So one of the rays goes parallel and passes through the focus after reflection. We can use the fourth rule here. Allow the ray to strike the pole this way and this would get reflected back. So if you draw by using proper scale, you would find that both the reflected rays move parallel to each other. And in the second chapter you will read, the second part of this chapter is refraction. So if these are the two rays which are moving parallel, there may be some change in optical density, which we call it as a refraction of light. So because of refraction, the rays might meet at some point very far away. So we can say if the light rays are meeting, the image would be formed at infinity. Image is formed at infinity. And the second important thing is, because the rays are moving and they are below the principal axis, it would form a real image. Real matlab inverted, so it is real inverted, and if by chance they are meeting at some point very far away, it would be highly enlarged. So this is about object at focus. Let us come to the last one in the concave mirror, object between pole and focus. Object between pole and focus. So let us take a concave mirror. Draw the principal axis, pole, this is focus, and this is the center of curvature. We are keeping the object between pole and focus, so this is the object now. So one of the ray goes parallel to the principal axis, and after reflection it has to pass through the focus. So this is the reflected ray. And we can take a second ray, strike it at the pole this way. If this is the incident ray, the reflected ray would go somewhere like this. Now see these two rays. If I draw the rays again, let us draw this ray again. So this would go somewhere this way. So this is the reflected ray. Now these two reflected rays, the two reflected rays are diverging. Therefore these two rays, they would never meet. These two reflected rays, they will never meet. So what we can do, for us it would appear as if they are meeting at some point this way. If you extend the two reflected ray backwards, you would find that they appear to meet at some point which is behind the mirror. So this is the image. Now these rays are not meeting by themselves, so the image nature is virtual, and if it is virtual it has to be erect, and if you see the size, the image is magnified and image is formed behind the mirror. Okay, so these are the 6 different diagrams in concave mirrors. Now let us come to the image formation in convex mirrors. Image formation in convex mirrors. So let us draw a convex mirror first and mark the pole and focus. So we have a convex mirror this way. We have got the focus. We have got the center of curvature at equal distance from pole and focus. I think so we have marked it wrong. We can take it a little bit further. So I think this would be the appropriate distance. And object has to be kept on the left side. Now if you see the diagram, we don't have any position here. On the left side of the mirror, we don't have any fixed position. If I can't keep the object on the right side because this part would become opaque. So I need to keep the object on this side. I have to keep the object this side. And there is no position here. So what we can do is we can take 2 different positions. The first one, let us take object at infinity. This would be one case, and the second case would be object at a finite distance. Object at a finite distance means object anywhere. Object anywhere between infinity and the pole. So let us take the first case, object at infinity. Draw a convex mirror, sorry. We have a convex mirror. We can draw the principal axis. This is the principal axis now. Pole, focus and center of curvature. Now when the object is at infinity, the rays must be coming parallel. So we have kept the object at infinity, so the rays are coming parallel. So let us say this is one ray, and let us say this is the second ray coming towards the mirror. Now because this is a diverging mirror, the rays would appear to pass through focus. So this is one reflected ray. Extend it backwards, it would appear to pass through this focus. And draw the reflected ray for the second ray also. If you draw the reflected ray, this would be the reflected ray, and extend it backwards. This also must appear to pass through the focus this way. So where is the image formed? Image is formed at focus, which is point sized. It is virtual because the rays are not meeting by themselves. If it is virtual, it must be an erect image. Okay, this is object at infinity. The second case is object at a finite distance from the mirror. So let us draw the second case. Object at a finite distance. So if we take the object at a finite distance from the convex mirror, first of all let us draw the convex mirror first. So this is the convex mirror. We have the principal axis, this is the pole, focus and the center of curvature. So object is at a finite distance, so let us keep the object here. So according to the rule, one of the ray goes parallel to the principal axis. Let us say this is the incident ray. It would diverge in such a way that it appears to pass through the focus after reflection. This way is the focus. We will take a second ray and strike it at the pole. So this is the second ray. It would reflect with the same angle this way. Now you can extend the reflected ray to get the image. So image is formed here. So this is the image and this is the object. So what is the nature? It is virtual. It is erect. See the size of the image. It is smaller than size of the object. So we can write it is a diminished image. And where is it formed? Image is formed between pole and focus. So these are the ray diagrams in concave and convex mirrors. Now these diagrams are very important for your board examination. Every year you get two diagrams either from the lenses or from the mirrors. So you have to practice these diagrams properly. You need to remember where is the object and how is the image formed. You must remember the position of image also, because these diagrams would be very important to solve the ray diagrams. So in the next lecture we will be talking about the important concept of this chapter, the mirror formula, and we will also be trying to understand the sign conventions which are used to draw the ray diagrams or to solve the numericals. So practice these diagrams and keep liking the videos, subscribe the videos to get more videos related to your subject. Thank you very much.